Chocolate is one of the most beloved foods in the entire world. Millions of tons of chocolate are produced and consumed globally every single year.
Behind every chocolate bar lies an extraordinary industrial manufacturing process.
Modern chocolate mega factories operate around the clock to meet global demand.
The journey of chocolate from raw bean to finished bar is truly remarkable.
Chocolate has a rich history stretching back more than 3,000 years.
10, 11, 12 beans for the pot.
A fair exchange. Thank you.
Today, chocolate is a multi-hundred-billion-dollar global industry.
All chocolate begins with the cacao tree, known scientifically as Theobroma cacao.
The name Theobroma means food of the gods in Greek. Cacao trees grow only in tropical regions within 20 degrees of the equator.
Cacao trees produce large, colorful pods that grow directly on the trunk and branches.
Each cacao pod contains between 20 and 50 cacao beans, surrounded by white pulp.
A single cacao tree produces only enough beans for about 1 kilogram of chocolate per year.
Cacao pods are harvested twice a year during the main and mid-crop seasons.
Harvesting is still done almost entirely by hand, using machetes and long-handled tools.
During fermentation, naturally occurring yeasts and bacteria break down the pulp.
The fermentation process typically lasts between 5 and 7 days.
Heat generated during fermentation can reach up to 50 degrees Celsius inside the pile.
This heat kills the cacao bean seeds and triggers important chemical changes inside.
Precursors to chocolate's rich flavor compounds are formed during fermentation.
Without proper fermentation, the resulting chocolate would taste flat and bitter.
After fermentation, the cacao beans must be thoroughly dried before export.
Drying reduces the moisture content of the beans from about 60% to 7%.
In wetter regions, mechanical dryers are used to speed up the drying process.
Proper drying prevents mold growth during storage and transport.
The color of the beans darkens, and the flavor continues to develop during drying.
Cacao beans arrive at chocolate factories in large shipping containers from producing countries.
The fermentation level looks good, right around 75%.
And the moisture reading?
Also within tolerance.
Accepted beans are stored in climate-controlled warehouses to preserve their quality.
Ecuadorian Nacional beans with delicate floral aroma. Beans from Madagascar are known for their fruity and acidic flavor characteristics.
Ecuadorian Nacional beans are prized for their delicate floral and nutty aromas.
Large mega factories may store thousands of tons of cacao beans at any given time.
The first step inside the factory is cleaning the raw cacao beans.
Magnets are used to extract any metal fragments that may be present in the batch.
After cleaning, the beans are roasted in large, rotating drum roasters. The roasting temperature typically ranges between 120 and 150 degrees Celsius. Roasting time varies from 15 minutes to over an hour depending on the bean and recipe.
During roasting, hundreds of complex flavor and aroma compounds are formed. The Maillard reaction during roasting creates the deep, rich brown color of the beans.
The cracked beans are then passed through a winnowing machine.
Winnowing uses air currents to separate the lightweight shells from the heavier nibs.
The remaining nibs are the key raw material for all chocolate production.
Nibs contain approximately 50% cocoa butter by weight.
The aroma on the first sample is
Winnowing machines in mega factories can process thousands of kilograms of beans per hour.
The grinding process crushes the nibs into a thick,
dark liquid called cocoa mass.
Heat generated by grinding melts the cocoa butter naturally present in the nibs.
The resulting cocoa mass is the base ingredient for all types of chocolate. Cocoa mass can be further pressed to separate cocoa butter from cocoa powder.
For chocolate making, additional cocoa butter, sugar, and milk powder are added to the mass. The mixture is then passed through a series of steel rollers called refiners.
Refining reduces the particle size of the mixture to less than 20 microns.
Particles smaller than 20 microns are imperceptible to the human tongue, creating smoothness.
After refining, the chocolate mixture undergoes a process called conching.
Conching was invented by Swiss chocolatier Rodolphe Lindt in 1879.
In conching, the chocolate is continuously mixed and aerated in large conching machines. Conching can last anywhere from a few hours to several days, depending on the desired quality.
During conching, volatile acidic compounds evaporate, reducing bitterness and harshness.
Conching develops and rounds out the complex flavor notes in the chocolate.
Additional cocoa butter and lecithin are often added during conching to improve texture.
Tempering is a precise heating and cooling process that controls the crystallization of cocoa butter. Properly tempered chocolate has a glossy surface and a satisfying snap when broken.
The chocolate is then cooled to around 27 degrees Celsius to encourage stable crystal formation.
Finally, it is reheated slightly to 31 degrees Celsius to eliminate any unstable crystals.
Cocoa butter can form 6 different types of crystals, but only type V crystals are desired.
Type V crystals give chocolate its characteristic gloss, snap, and smooth melt in the mouth.
Continuous tempering machines in mega factories handle thousands of kilograms of chocolate per hour.
Air bubbles inside chocolate bars are a sign of poor manufacturing quality. For hollow chocolate figures, a process called shell molding is used.
Filled chocolates have a chocolate shell that is filled with ganache, caramel, or praline.
The cooling tunnel gradually reduces the temperature of the chocolate to set it firmly.
Properly cooled chocolate contracts slightly, allowing it to release cleanly from the mold.
Some chocolate products are made through a process called enrobing.
Enrobing involves passing a filling or center through a curtain of liquid chocolate. Wafer bars, biscuit centers, and caramel fillings are commonly produced by enrobing.
Chocolate dripping collected and recycled. Excess chocolate dripping from the enrober is collected and recycled back into the process.
Enrobing machines in mega factories can coat thousands of individual pieces per minute.
The speed and precision of modern enrobing machines is a marvel of food engineering.
Check weighers ensuring correct chocolate weight. Weight check weighers ensure every product meets the specified weight requirements. Texture analyzers measure the hardness and snap of chocolate samples from each batch.
The snap is very clean.
Yes, and the fruity notes are quite pronounced on the nose.
I'm getting a slight bitterness on the finish.
See this peak here? That indicates the presence of tin.
Yes, but the concentration is very low, well within the acceptable limits for heavy metals.
Temperature and humidity in the production area are constantly monitored and controlled.
Detailed records of every batch are maintained for full traceability and food safety compliance.
Barcode and batch code printing systems label every package for traceability.
Deforestation and unfair labor practices in cacao farming are major industry challenges.
Many companies have committed to sourcing 100% certified sustainable cacao.
Fairtrade and Rainforest Alliance certifications help ensure better conditions for farmers.
As technology and awareness continue to advance, the future of chocolate will be both delicious and more responsible.